Multiplying and dividing rational expressions. So we're only going to multiply and divide. Adding and subtracting is the next lesson. Rational expression. What is a rational expression? The word ratio is in that. Not ration. A ratio is in that. That means that if you have 2 to 3, but also we could write it like this. So rational expressions are fractions. Here it shows 35 and 40. When you reduce it, 5 is in both, so you could cross that out and it reduces to 7 over 8. Now 5 over 5 reduces to 1, never 0. It divides by 1. So there's always a 1 there that's multiplied that we don't always write. So if everything cancels, you're always left with a 1. We could do quadratics, which this factors to this. What does that mean? That means if I multiply x plus 5 times x plus 2, it's written like that, but it's FOIL, right? First, x squared. Outer is 5x and 2x, and inner. And then last are 10. So I get x squared plus 7x plus 10. So when we factor these two things, since a is 1, you're able just to think what multiplies to negative 6 and adds to negative 1, negative 3 and 2. What multiplies to 10 and adds to 7? Since these are both positive, these are both positive. Now those cancel, and this is your final answer. The thing about simplifying expressions, if you ever have x in the denominator, 3 over x, there is a number that does not exist for this. This denominator cannot be 0. So in order for this to be 0, dividing by 0, x cannot be 0. So you have to state your restrictions from the original problem. If you don't know it from the original problem, you have to do it from the factors of the original. So let's look at example 1. So example 1 says state when the original expression is undefined. So right here I can't tell what x has to be for this whole thing to be 0. So we're going to have to factor it. So each one has an x, the lowest power, so you take out an x. Each number could be divided by 2. The top they're not working on right now, they're working on the bottom, just took out the 2x. Now we have two quadratics. So the first one you got to think of what multiplies to negative 4 and adds to negative 2, negative 6 and 4. Second one, what multiplies to negative 4 and adds to 3, negative 4 times negative 1, or negative 4 minus 1 is the 3. So from this point, these two are now equivalent. So this is the point that you could say, what would make this denominator 0? So we use the zero product property, which is the paragraph below. So from this point right here, when there's a number in front, x can't be 0, because that would be 2 times 0, which would be 0. So x cannot be 0. This one, take the opposite. X cannot be negative 4. Or this one, x cannot be 1. Another way you could think of it is x minus 1 equals 0, so x equals 1. Okay. Or if you had a fraction, this is just a separate example, if you had 2x plus 7, and you set that to equal to 0, you're always going to get this as your numerator, this number with the x as your denominator, and this is a positive, so we'll need the opposite sign. So this is just a separate example. My mouse is right there. It also works with something like this. This is my numerator. This 1 is my denominator, so 4 over 1, and I take a negative because it's opposite sign. This paragraph just explains what I did. Okay, so we have our denominators 2x, x plus 4, x minus 1. When we wrote it all like this, the x plus 4's cancel, so all I have left in the numerator is x minus 6, and the denominator is a 2x and x minus 1. This is easier to see. We have 3 factors. So the first one, set it to 0, so x cannot be 0. Second one, set it to 0, x cannot be negative 4, and x cannot be 1. I know this is saying equal to, but it's saying where is it undefined? It is undefined when x equals 0, when x equals negative 4, and when x equals 1. And that is why here I say it cannot be these three things because that's where it is undefined. For the check, let's write it over here. So the original, I can't tell what it has to be 0 to cancel out with that negative 1. So we have to factor it. The first one is what multiplies to 1 and adds to 2. Well, that's x plus 1 and x plus 1. The second one is a quadratic, but a is not 1. So I can't just say 1 and 3 because we have 4 here. So there's two things it could be. It could be 2x and 2x. But looking at my multiple choice answers, I'm going to try a 4x, maybe this one. So 4x and an x. And then to multiply for 1, I have a positive and a negative for negative 1. So we have to add to 3. So remember, FOIL is the OI is outer and inner. So I got 4x minus 1x is 3x. So that's the factor of that. So that's factored. So from this point, I could say what x cannot be. This is the numerator. This is the denominator. And opposite sign, since it's minus, it'll be a plus. And 1, opposite of that, is negative 1. Those are the two places it's not defined when x are those two values. Now let's cancel these two, x plus 1, and we're left with that, which is this one right here. You could also factor this by grouping. Remember, you multiply a times c and have to figure out what adds to b. Okay, here's one with x and y. We factor. Looking at this first one, they both have an x. This one, there's nothing I could factor out. This one, nothing I could factor out, nothing factor out, so it's just that. Now looking at these, these are really close. These do not factor because that's 2y and 1y. These are really close, the 6x minus 5y and 5y minus 6x. So right here, 6x is positive and here it is negative. So if I change that to a negative 1, then it'll change the signs of this, negative 6x plus 5y. So these are equivalent to this. Now my 6x is negative, my 5y is positive. Now you could cancel those two out. So you have a negative 1 and x and this in the numerator, and only the x plus y in the denominator. Either one, you could write it either way. What can x not be? This one doesn't have to say where it's undefined because I have an x and a y in the denominator. It's not only x, so it's fine. Here's the check. So here is this. I'm going to rewrite it. I'm going to keep 3x minus 7y. This one I could take out an x squared, the lower power. This one stays. And this one, these two are similar, except again 7y is positive, here it's negative, positive, here it's negative. So I'm going to change this to negative 1, negative 7y plus 3x. Now these two are the same. So I'm left with 5x minus 1, x squared, and 5x plus 1. Now these two are not the same because only the ones switch signs. Both terms have to switch signs. The 5x are the same. Both terms have to switch signs in order to take out a negative 1. And again, we have an x and a y, so we can't really say what's undefined. So those are simplifying multiplication and division. Now, most of these are either quadratic or you have factors that are a plus b, a plus c, something like that. What we are going on now to do are expressions. Expressions are just looking for the same base and then you could divide. Now remember, when we multiply, you multiply straight across. So A times C, B times D. But when you divide, you flip the second one, not the first one, the second one, and you change it to multiplication. Then when you're changed to multiplication, you could go straight across AD and BC. So what they show you is prime factorization here. I'm going to start with just the problem. For example, I don't know what grade they do this, but 12 is 6 times 2, which is 3 times 2 times 2. Those are your prime numbers. And that's what they're showing this. 2 times 2 times 3, there's my 3. 2 times 2 times 2 is 8. 3 times 3 is 9. Now let's look at the variables. X to the second power means I have x times x. Y to the third power is y times y times y. You can do this. You can do it this way. I will show you a different way with the next problem. When you do it this way, you have everything laid out. You cancel what you can. So there's 1, 3, 2, 3s, 1, 2, 3s. 1, 2, 2s, 1, 2, 1x, 1x, 1y, 1y. No more x's, no more y's. So you're left with this, x squared to y cubed. Where's the other y? Did I cross off an extra y? I did. This y should cross off with this. These 3 y's should stay. So this is the y that crosses out. Okay, so let's do the division one. So remember division, you flip the second. So 4c goes to the numerator, 30 goes to the denominator. Now, I'm going to show you how I do it. Either way is fine. But what I do is first look at the numbers, see what you could reduce. 4 and 6 is 2/3. 10 into 30 is 3. What's left there is a 1. You could write it or not. So that's all I could do with the numbers, because now I have 9 on the bottom and 2 in the numerator. Now let's look at the variables. There's d to the 5th in the top, the numerator. The denominator has 1 and 2, which are 3. So 5 minus 3 is 2. Now why I wrote it in the numerator? Because there's 5 and then 3 on the bottom. So those 3 cancel and you're left with d squared. Now C, I have 1 on the numerator. I have 1, 4. Or you could think 1 and 1 cancel, so I'm just left with 3 in the denominator. Wherever there's more, numerator or denominator, that's where the bulk stays. And so I get this, which is this one. Okay? So either way, you could do prime factorization or just subtract, because when you divide same bases, you subtract the powers. You just got to remember, if the bigger number over x to the 5th, subtract them, I get x cubed, but that is in the denominator because that's where the higher power is. Okay, here's a word problem. You have 2 of these. They're a planter that they want to compare. So it's asked for the write and simplify an expression that represents the ratio of the area. So ratio is a fraction or division. So you're going to get this first one divided by the second one. And remember, when you divide, you flip the second one, so it becomes multiplication. So this goes to numerator, this to denominator. Now I have these 2 expressions right there. I know those cancel. The other 2, we got to factor to see if anything else cancels. What multiplies to 50 and adds to 15? 5 and 10. What multiplies to 200 and adds to 30 is 10 and 20. So the 10s also cancel. So we're left with x plus 5 over x plus 20. And it's a good habit, never going to be counted wrong. X cannot equal 20, negative 20. Because when x is negative 20, that denominator is 0. You have one that is division and then one that is just multiplication. It says find the area, so area is multiplying. You don't have to flip anything. Okay, so let's look at complex fractions. Complex fractions means we have some monomials, some binomials, all different things you got to figure out. And what it means is that you're dividing two fractions. So we have this first one divided by this second one. Flip it. Looking at this, this could be thought of difference of squares right here, which is 2x plus 2y, 2x minus 2y. But then there's a 2 common in this, and there's a 2 common in this, which means you're going to take out a 4. Or you could just take out the 4, get the difference of squares. Right here we could start canceling the x, and then 3 goes into 6 2 times. 2 goes into 4 2 times, so we're left with that. Difference of squares is x plus y, x minus y. So they got x plus y, x minus y, and it cancels with the x minus y. So all this first one canceled. The second one, I'm left with the y and 2x plus y in the numerator. If you'd want to say where it's not true, you could say y can't be 0, but that's not really necessary because we have x and y. Okay, so here's one complex fraction. We have rational expressions in the numerator and denominator. Since it's division, I'm going to write that one, and then I'm just going to flip this one. So this one is difference of squares, whereas different than the one up here is 4 was able to take out of the x and the y. This one only has the 9, so it's x plus 3, x minus 3. And this one takes out a 2, x plus 3y. I need a y because it's y squared. Now I can start canceling with a different colored pen. I got 1x, I've got 2 x's, so that cancels. Y is all by itself. I've got x plus 3y, x plus 3y, so all I have left is this, the y, the 2, this 2, and an x. So I got x, x minus 3y divided by 2y. Okay. That is it for 9-1. It has a lot in it because of the factoring, but just try these, do the best you can. We have 2 to 16 evens, and then 17, 19, and 22. All right, let me know if you have questions.